Hello everyone, welcome to Style3D Simulator. This lesson is the 8th part of the in-depth simulator tutorial series. The key topic is an explanation of the Simulation tab in the simulator. Open the UE project and mount the clothing. Here, I'll first use the automatic clothing skinning function to adapt the clothing to the model. Next, let's start explaining the various sections in the plugin. For the rendering mesh type, you can use the default deform mesh. This is a custom clothing rendering pipeline by Style3D, supporting multiple UV channels. Open Preview is often used to check whether clothing skinning or pose fighting has been successful. Bind properties include shoulder width, symmetry. This is generally used for automatic clothing skinning, and default values are recommended. Export obstacle is used to export UE model assets. In the collision group, official preset collision groups for model assets are available. Users can also add collision bodies themselves, but it is currently not supported to collide with mesh bodies in the scene. Collision can only occur with mesh bodies mounted under the Style3D character component. Style3D Runtime is the runtime mode, and during real-time simulation, clothing simulation mode should be selected. The following two modes are only used for offline simulation. With real-time simulation mode enabled, adding components allows interaction with the clothing. Click on the top left window option, then click on Place Actor, search for the Style3D Interaction Actor component, and drag it directly into the 3D window to complete the addition. Garment fitting is also a clothing adaptation feature. When the UE model's body shape changes, you can check Enable to activate, then click on Garment Fitting to automatically adjust the size of the clothing to fit the current body shape. Garment Fitting will generate a new clothing adaptation file, cache_01. Check Load Fitting Cache and then copy the generated cache_01 into the adaptation file to use. This completes the clothing adaptation for changes in body shape. Solving properties is specifically used to control various numerical values during simulation. Usually, keep the default selected options, and please do not make changes. Animation mode: if there is no animation data for the human body, you can disable this option to improve performance. Animation smoothing, when enabled, can alleviate abrupt changes in human body animation, enhancing simulation stability. If the model asset has animation, you can check this option. Backside and sideways are for generating backside and sideways meshes. When simulating certain outerwear, the inner layer of the clothing may be exposed if the backside option is not selected, otherwise, the inner layer will not appear, leading to perspective issues. Collision convex, when selected, accurately supports ray detection, mouse picking, and similar functions. When using the Interaction Actor component, make sure to check the Convex Collision option in the solver parameters. Fictitious force is used to simulate inertia, and users can activate it as needed. With the Strain Map Color option enabled, you can observe the stretching of the clothing. Here, a new material ball needs to be created. Double-click to open it and add a vertex color for the basic color. Click on the material node, then search for Clot in the bottom left corner and check to use fabric. After saving, change the clothing material ball in the clothing editor. After the change, click Simulate to see the stretching of the clothing. Vertices will have colors indicating stress on them. You can clearly see significant differences in the stretching of the clothing between movement and stillness. Now, let's talk about the solver properties. You can change the solver type as needed. GPU ID is the GPU number used for simulation. Time step, S, is recommended to be set to 0.01. Not exceeding 0.03. If set to 0, the time step will be automatically adjusted based on the frame time interval. Substeps can divide a complete physical frame into several substeps, suitable for scenes where human actions are large or FPS is low. The higher the iteration count, the more accurate the solution result, but the calculation cost is higher. Gravity controls the acceleration due to gravity. Air damping controls the numerical value of air resistance. Self-collision stiffness should use the default value and not be less than 0.5. External thickness: the larger the value, the less likely penetration occurs, but the gap between clothing may increase. Ground property can adjust friction. Wind property can simulate a scenario with wind. Light channel can change the lighting mode for clothing. Alright, that covers all the content for this lesson. Feel free to give the video a like, share it, and participate in the comments section. See you in the next video.